Welcome friends. Today I will discuss 10 important multiple choice questions in this artificial intelligence area, and we will be keep discussing these questions every day regarding AI area also and machine learning areas also, as these two are very important areas in GATE DA paper. So let us start today's session with this AI area, artificial intelligence area. We will discuss 10 questions. So what are the topics in this one? Informed search, uninformed search, predicate logic in AI, propositional logic in AI. Then there are topics like approximate inference in Bayesian network, that's in the GATE syllabus, and knowledge representation in AI. These are key topics in AI area. So let us discuss the first question. You read this question. So you read the following two statements. This is a question regarding propositional logic. So statement 1 is, if a candidate is known to be a criminal, then he will not be elected. And statement 2 is, if a candidate is polite, he will be elected. Now, which one of the following statements follows from S1 and S2 as per sound inference rules of logic? You will see many of these questions during GATE preparation, in GATE exam, many of these questions you will see. So, how to solve these questions? See, first method I am telling you is very simple. These questions are very common sense logic. Right from itself, without doing any mathematics, you can solve it. Like this you see. If a candidate is known to be a criminal, means it's a negative statement. Candidate is known to be a criminal. Then he will not be elected. Okay? Because he is a negative person, negative area. If a candidate is polite, okay, he is polite, he will be elected. Now this is a negative statement, this is a positive statement. Now downside you can see that where negative negative are matching or positive positive are matching, only that thing will be true. So if a person is not known to be a criminal, not known to be a criminal means it's a positive statement. He is not polite. That's a negative. So this statement is positive, this part, and this part is negative. This shall not be correct. This is wrong. If a person is polite, positive statement, he is not known to be a criminal. He is not criminal. Again positive. So this positive, positive is there. This shall be true, B. Now coming to C. If a person is not polite, negative statement, he is not known to be a criminal. This is positive statement. Positive, negative, not matching. We have to match. Okay. If a person is known to be a criminal, negative statement, he is polite, positive. No, negative, positive will not match. So only B is matching, positive, positive. If a person is polite, positive statement, he is not known to be a criminal. Means he is a good person. So B is positive and positive, positive, so B is true. From direct inference itself we can get it, but in mathematical terms, as a propositional logic terms, this will be explained like this, that Cx, X is known to be a criminal, statement Ex, X will get elected. Then Kx, X is polite. Then S1, statement 1 is, S1 is Cx implies that not Ex. This is a symbol of not. Not Ex means if a person is known to be a criminal, he will not get elected. And statement 2 is, if the person is polite, means he will get elected. Kx implies Ex. Now if we reverse it, not Ex then implies not Kx. From this system of both sides we are putting not, so that this not Kx or not Ex can match this one. So that will imply now from hypothetical syllogism is equivalence. Now, not kx is equal to cx will lead to not kx or kx will lead to not cx. Means kx is if a person is polite and not cx is, then he is not known to be a criminal. Because x is known to be a criminal, so not cx is, he is not known to be a criminal. So from this we can derive if a person is polite, then he is not known to be a criminal. That was the statement B. So you can directly also solve this question from your common sense reasoning, or you can apply this mathematics, the propositional logic symbols, and get it. See, what is the problem with propositional logic or predicate logic problems is that sometimes you may be too afraid of the symbols. Understand the symbols, those will be easy. If you are too afraid of symbols, then you will lose even very common, very simple questions. This is a very simple question, you see. Given P not S is equal to 0.6, probability of some event not happening is 0.6, then what is the probability of event happening? Very simple. 1 minus 0.6, that's all, 0.4. So if you are afraid of symbols, that what is P not S means, then what is PS, then you may be a problem. Otherwise, probability of not happening an event is 0.6, probability of happening the event is 0.4, very simple. Here answer is D, 0.4, S is opposite of not S. Now coming to this one, select the most appropriate situation for that a blind search can be used. Where a blind search can be used? What is blind search? It's uninformed search. We don't have any information. We are roaming in blind. So how are we going to operate then? Because suppose in this room, I am closing my eyes, I am blind, and now I am trying to search a chair. So what will happen? I will go each and everywhere in the room. Everywhere I will go. So as a result, it will take much time, and I can then access only limited area. It's a small room I can search, otherwise in a big room I will be in trouble because I am not able to see anything. I am blind. That simply means blind search can be used where small search space is there. In real life situation, everywhere it can't be used. Only where complex games, very difficult, small search space is there, blind search will be useful, uninformed search. So here you see, blind search is also known as uninformed search, and it doesn't contain any domain information such as closeness, location, etc. So these are the search algorithms: uninformed or blind search, and uninformed or blind search has these: breadth first search, uniform cost search, depth first search, depth limited search, iterative deepening, bidirectional, and informed search has only two: best first search and A star search. So in uninformed blind search, what is breadth first search? We are going one level, we will explore all the nodes in one level. Then we will come down and explore all the nodes in the second level. Then come down, explore all the nodes in the third level. Like that. At every level we will explore all the nodes. So it will be time consuming. If goal is much below, then it will take time. But ultimately we will find the best solution. Because at any level, if shallowest level, the solution is there, we will find it, the best solution. So breadth first search is quite useful. Then there's uniform cost search, where we look at the cost and go as per the cost and search. Then depth first search. First we will deeply explore all the nodes in one column. Then we will go to the next column, explore all the nodes. Then third column, like that. So much more here breadth first search, a lot of memory is required because we have to keep in mind all the nodes. But in depth first search, memory is less required because we can completely explore all the nodes in one column only. Then we go to next column. If goal is found, it becomes very easy. But depth first search goes into problem where many solutions are there, or we are not able to find the solution. It's too deep. Then we may not be able to find the best solution. We go to depth limited search, where we define up to a level only we will go, and then we will go to the next branch, then next branch, like that. So in depth limited search is a combination of breadth first search and depth first search. And iterative deepening depth first search is a type of depth limited search where initially we go up to only a level, then if goal is not found, we increase the level, come down. And then again if goal is not found, we again come down. Wherever goal is found, we stop there. So that is iterative deepening depth first search. And bidirectional search, we go from both sides, from goal side also, from top down also, and top down bottom up both we go and found very quickly, but memory required will be much more. Then in informed search, where you have got some knowledge, we have got some heuristics, I am opening my eyes and then looking after the chair. Very simple. There is best first search here again. This best first search means, or greedy best first search also is there, means we are only looking that from intermediate state to goal, how much cost is there, and only we see least cost and go for that exploring. While in A star search, we take two things, we sum out two things, from our initial state to intermediate state, what is the cost, and from intermediate state to final state, goal state, what is the cost. We sum up them and we look for the minimum cost there and we go in that direction. So this is the most optimized search, takes a bit of memory, but most optimized, it takes entire information, HN plus GN. Now coming to next question, among the given options, which is not the required property of knowledge representation? This is a knowledge representation question. Inferential efficiency, inferential adequacy, representational verification, representational adequacy. Here you see inferential efficiency is of course required because we want to create new knowledge on the basis of existing things. Inferential adequacy is also required because without that we can't infer new knowledge. Representational verification is just a vacuum. There is nothing like representational verification. It doesn't mean anything. Representational adequacy is there. We have to represent existing knowledge in a good way. So the answer here is not the required property of knowledge representational verification. Knowledge representation is a part of artificial intelligence that leads with AI agent thinking and how their thinking affects the intelligent behavior of agents. So these four properties are required: representational accuracy, inferential adequacy, inferential efficiency, acquisitional efficiency. So that representational verification is not here. So that's the answer. You see, what is representational accuracy? Ability to represent all kind of required knowledge. Whatever knowledge is there, if we can represent it, it's representational accuracy. Inferential adequacy, ability to manipulate the representational structures to produce new knowledge corresponding to existing structure. Inferential efficiency, ability to direct the inferential knowledge appliance into the most productive orders by storing suitable guides. And acquisitional efficiency is the ability to obtain the new knowledge easily using instructive methods. So you can go through it and see that how knowledge representation can be done. See here, knowledge is like a structural knowledge, relationship between objects, concepts, types of knowledge, declarative knowledge, object facts, heuristic knowledge as we are seeing, rules of thumb. Heuristics means some guideline, some rule of thumb, something from our experience, some information we have found out, that's heuristics. And meta knowledge, knowledge about knowledge. Knowledge of knowledge itself, that is meta knowledge, and procedural knowledge, rules, procedures and all. Now coming to the fifth question, which term describes the common sense of the judgmental part of problem solving? problem solving we are trying to judge something. So common sense of judgmental part means we are trying to get some hint. Of course, it's heuristics, very simple. Values based critical analytical is nothing, heuristics. That's called heuristics, common sense of the judgmental part of the problem solving. Here you see in problem solving, the heuristic describes the common sense. So that's heuristics is the answer. This is something about heuristics you can go through. And coming to the next question, if according to the hypothesis the result should be positive. See, according to hypothesis the result should be positive, result is coming positive, but in fact it is negative. Then it is known as the result was negative. Actually result should have been negative. In fact it is negative. Ground truth is negative, but as per our hypothesis result is coming positive means we are getting false result. So false words will come and we have got positive result. So it's a false positive hypothesis. Okay? False positive hypothesis. The false positive hypothesis means that according to results you have that condition, but in reality you don't have it. Such as for a medical test, you went for a COVID test. And what happened? You were not having COVID. But the test shows that you are having COVID. What it will be called? It will be false positive. While if you are having COVID and result is coming negative that you don't have, then it's a false negative. But if you are having a COVID and result comes yes, then it's a true positive. So here it's detection like this, detection null result in some signal processing thing. If signal is present and target was detected, true positive. Signal was absent and target was detected, it is false positive. Target was detected but there was no signal, false positive. Now signal was present but target was not detected, false negative. That is type 2 error, this is type 1 error. And then if signal is absent, the target was not detected, true negative. So like this, different types of errors are there. Now coming to the next question, which of the given statement is true for conditional probability? Try to understand conditional probability means how one event is related with other event. Given that one event has happened, what is the probability of this event has also happened? So conditional probability gives 100% accurate results. No, probability is probability, nothing can be said 100%. Conditional probability can be applied to a single event. No, there are always two events. One event, on the basis of one event only we are taking second event. Conditional probability has no effect or relevance on independent event. Yes, if two events are independent, separate, then nothing is common, then conditional probability will be the same, means it will not have any effect. It will be equal to the probability of those events. So that's the answer. Conditional probability has no effect or relevance on independent events. Like this you see conditional probability. The formula is probability of A over B is equal to probability of A intersection B divided by PB. So if it is independent, then probability of A over B is equal to PA, no effect, and probability of B over A is again PB. So given that B has happened, has no relation with PA, because what will happen there, these two circles will be separated out. Now coming to this again, propositional definite clause, which closely resembles propositional definite clause. Resolution no, inference no, conjunction no, first order definite logic. Definite is there, there again definite is there. This is something where this predicate logic or first order logic and propositional logic are matching. So first order definite logic is the answer, because they are disjunct of letters of which exactly one is positive. So if you see propositional logic, these are the symbols, and conjunction symbols that some people write as inverted U, but we write it inverted V. So P inverted VQ, that is and then R, P union Q, not, negation, this is negation symbol you have to remember, XOR, like this, implication, and double implication, both imply each other. So like this we have to learn this propositional logic. Now ninth question, suppose you toss a coin 100 times, probability question, that head occurs 42 times. You did. If you will do it long number of tosses, then it will be 0.5, but in your experiment you found that you tossed it 100 times and you found 42 times head has happened. You use maximum likelihood estimate to obtain pH to be P. Maximum likelihood estimate MLE is P. However, you also know that the typical pH is close to 0.5 and you use this prior knowledge, 0.5 is normally happens, to do maximum a posteriori estimate. MAP you have to do. The estimate of pH obtained using MAP estimate is Q. What is the relationship between P and Q? That's the question. So it's the relation between MLE and MAP. So here you see, maximum likelihood estimate MLE is simply what we found in our experiment, that is 42 divided by 100 is 0.42. That is the probability we derived from, probability of head we derived from our experiment. 42 times we got 100, so 42 upon 100 is equal to 0.42. Now priori knowledge we found that actually usually it happens is 0.5. So what will happen? We will modify this MLE on the basis of priori knowledge, and maximum a posteriori MAP estimate will be somewhere between 0.42 and 0.5, that is somewhere between MLE and priori knowledge 0.5. So Q will be more than P because P is 0.42, Q is lying between 0.42 and 0.5. So Q will be more than P and less than 0.5, in between. So P is less than Q is the answer for this one. P is less than Q, that is B. In statistics, maximum likelihood estimate is a method of estimating the parameters of an assumed probability distribution given some observed data. So whatever we have observed, on that basis we are estimating something, that is MLE, maximum likelihood estimate. And when we take priori knowledge also into account, or priori knowledge also into account, what we are having from the long back we are having that knowledge, if we are combining that, it becomes MAP. That's the way it goes. Then 10th question, last one. Consider the following Bayesian network. This is a Bayesian network. Here A implies C, A has an effect on C, B has an effect on C, and C has an effect on E. Then A has an effect on D and D has an effect on E. Now in conditional probabilities we will go reverse. So in estimating B, C will also have something to do, some role, E will also have a role. Now statement 1 they are telling that B is independent of E, B is independent of E given evidence at C. How can it be? Because C is having an effect on E and B is having an effect on C. So when C is having an effect on E, how can B be independent of E? Not possible. E will definitely have some conditional probability on B. Similarly, B is independent of A. B can't be independent of A because A is having an influence on C and E also. B is dependent on C and E in conditional terms, so B can't be independent of A. So both statements are actually incorrect. A is the answer. B is dependent on C, which is linked with both E and A, hence B cannot be independent of E or A. That's the answer. Thank you, and then we will see in your next question session.